Greetings. We have Guy Bourassa of Scandium Canada with us here to talk about the metal that is not on everyone's lips but should be. Just a bit of an intro. Back in the start of the rare earth boom, back in 2009, people often attach scandium to the rare earth group. But now that we've got a situation where there are a plethora of rare earth stories out there, we still have only a very small universe of scandium stories. And scandium is scandium is an interesting situation because it's a metal that has actually a very small niche market at the moment, but very highly priced. And its potential for adoption is enormous, particularly in things like aerospace, where it's used in alloys that lighten the weight of planes and thus get them increased distance and performance. So Scandium Canada is the leading scandium story in Canada.
So people are looking at this as, oh, that's interesting. Yeah, but what do we have in North America? What do we have in Canada? What is, are we able to trade? We don't like to trade on Australian market, so what is there? And when you start to do your homework, well, there's not a lot of scandium related companies. And obviously in North America, the leading project is the Crater Lake project of Scandium Canada. By the way, the only primary source of scandium currently being worked around the world, because everybody should know that currently the supply comes as a byproduct of something else, a laterite nickel mine, a ilmenite or titanium mine. So it's always a byproduct. The real advantage of Scandium Canada Crater Lake project is the fact that it's a primary source. So if you are a end user, you will like to be sure that your supplier is going to be able to provide, and all of the pricing is going to be related to the specific material. So as we are evolving, and I suppose that the market this week reacted or is in anticipation of federal funded grants to accelerate the development of infrastructures for critical mineral. There is large funds available in Canada specifically to help accelerate by grants and subsidies the projects. So we announced to the market in August that we had filed for two large, very large grants, and that could be announced any day now. And
Yep.
So I think that the market is in anticipation, timing-wise, of the grants being awarded. And then these two grants will allow us to complete the pre-feasibility of the project by this summer, 2026, and also
Yep.
all of the money required for the large bulk sample required to complete the feasibility study.
Right. How big is the bulk sample?
We already have 12 tons of material available. We
Yeah.
are currently working on this. We've been in the past working with SGS in Lakefield for the
Yeah.
pre-feasibility methodology review. Now we're working with CAREM in the province of Quebec
Yep.
to prepare for that. So that's, I would say, maybe more important. Well, of course, technical aspect is very important, but these days, more and more, the social acceptability, the involvement of the First Nations on which traditional land we're working. So we have been able to attract, as an investor, 5% investor, the Naskapi First Nation of Kawawachi-Kamak, just
Yeah.
close to Schefferville. Lately, we finally got an agreement in principle to have a access road built between Schefferville and the project. So
Yep.
to think about it, to have the acceptability of it, so that the logistic of the project is completely changed with a permanent access road. And as we're moving and discussing with the federal government and the First Nation on this, most likely the access road to the territory of the Naskapi which is going to be able to provide us with access to the mine. We're looking to get it mostly funded by federal funds, whether loan or whatever, and remove that from our capex, because it's not a road for us, it's a access road to the territory of the First Nation.
How much would that save if you can remove it?
Oh, gee, we're talking $300 million, $400 million. It's a 350 kilometers access road. But so all of it reduces the capex, but the fact that we change the logistic gets the hydromet plant closer to the mine. So instead of traveling 500, 600 kilometers to the south to do the conversion, we're going to be able to convert in Schefferville, establishing our hydromet plant in Schefferville. So reducing the transport cost and being more, I would say, friendly.
You mentioned federal grants. What about state, provincial grants?
Oh, we're also in discussions with them, Société du Plan Nord, in particular, which is a crown company that takes care of the development of the northern part of Quebec. So talking with them, they're in direct relation also with the First Nations. So we have a good, I would say, good surrounding that is supportive. And the Quebec government announced, was it in November, a plan, 5-year plan to accelerate also the development and opening up the Labrador Trough north of Schefferville, giving access to a lot of resources that are there, but cannot be financially viable without a road.
Because Quebec has moved from being a position of not even figuring in scandium considerations 5 years ago to being really the known source of produced scandium at the moment because of Rio Tinto's move into exploiting what was previously a stream out of their plant in Quebec that was just, I believe, going to tailings. That they're now exploiting. Now, I heard an interesting story recently, and I'd like to hear you comment on this, that they had actually pre-committed 6 years worth of sales to the US, to basically the Pentagon's scandium stockpile. So in fact, all this new production that they're coming up with is actually not adding 1 ounce of scandium to the global marketplace because it's already essentially spoken for.
I believe it's not fully correct because lately after the G7 meetings, Canada is now in charge of building for the allies a scandium stockpile, and they have made a deal with Rio Tinto to buy material and put that.
It's the Canadian government is buying it.
Yes, Canadian government for the G7. So he has the mandate, the Canada, to build a stockpile. They announced a deal with Rio Tinto to buy and build that stockpile for the G7 allies.
I also heard that there was a story that it was one of the assets that Rio Tinto had put, the new CEO of Rio Tinto put up for sale.
For sale, you mean?
Yeah, the whole.
Yeah, no, absolutely. It's being discussed. What we know is that the block and the production of that scandium oxide in Sorel is not to be closed.
No.
What is the owner gonna do? We don't know yet. Well, the new owner, if it does be sold, but we don't expect that it will, with the agreement that the G7 under Canada supervision has asked for that stockpile. One important point about that stockpile, because it can be used to market development. So what currently we are doing with our alloys, because we have not talked about the development of our 2 alloys, we can get material from Rio to support our market development efforts, pre-commercialization of our alloys. So as far as us we're concerned, it's it's still available, and we can still advance our development with Scandium Plus.
And of course, scandium is enormously versatile in the number of alloys that can be created from it. I think there are like 6 or 7 major metals and minerals with which it is alloyed to achieve various goals. But of course, the chief one of those is lightweighting.
Yep.
And lightweighting, of course, has applications in aerospace, but also has applications in interspace and other factors there. So that's that's fascinating, I think. And so you're really the Canadian champions now, after RTZ, of course, in the space. Now, have the large Quebec institutions, the household names, as we can call them, got behind the share register in recent years?
We were, the company was fortunate to have Quebec Inc. Name players in exploration stage.
Yes.
Most of these players are not allowed to go in the development stage. So we're in the middle of this. We are in discussion, of course, with some of the major players in Quebec as we are moving to the pre-feasibility study.
Yeah.
They're going to be teaming up with us as soon as we can confirm the grants that are moving the project forward. We're talking a budget of about $20 million Canadian to complete the feasibility study. So the next about 24 months would cost about $20 million. The grants that we've asked for roughly will bring about $11 million. So the balance is going to be, of course, raised as we move along. But that's not a lot of money to be able to complete the full feasibility study of a project of that size.
Have you been using flow-through much to finance in recent years?
We stopped using flow-through, I would say 2 years ago, a year ago. Now that we're moving into the development and there's less ground exploration work as we speak, we've been able to, you were talking or asking about the Quebec government involvement. We've been able to do a lot of metallurgical testing supported by grants from the provincial government, mostly provincial government. So that's what financed a lot of the SGS metallurgical tests for the pre-feasibility study.
You mentioned the Friedland flurry in Australia. Of course, the big challenge for Scandium is you sort of like build it and they will come, because you have to have more scandium production to then get the Boeings and the big European aircraft makers to actually start using scandium in more applications. Of course, in the short term, it could be a rising curve, in the sense that they could be using for components rather than the whole frames or the shells of the planes. Like seat mountings and things like that, to try and try it out and actually match the demand to the supply, because we have had this issue that of not enough supply of scandium for big airlines to actually make the jump and retool to make that change. Do you have technology partners on alloy testing and experimentation?
Yes, absolutely. And as we got that expertise and the relationship with the development of our two alloys, the 5000 and the 7000 series that we developed over the years, for which we filed patent applications internationally. We were able to get two specific alloys that are able to be used in advanced manufacturing. So
they're alloys with aluminium?
Yeah. Aluminum alloys, the 5000 and the 7000 series, which is a breakthrough, because when you do advanced manufacturing with laser bed fusion, the problem with some of these alloys is that micro cracks are created in the cooling period,
Right.
That's why we've been able to file a patent on this. Our alloys, modified alloys, do not generate micro cracks. So you can think now of using it in the structure of the hull of an aircraft because it
Yeah.
will qualify. So when we started announcing some of the characteristic and some of the results, third-party analysis results, we were called by large companies in the metal industry saying, guys, and cold calls on us, a small company. They said, well, we read your press release. If your alloys do what you see in that press release, we absolutely want to be discussing with you because this is a breakthrough. And we announced a couple of months ago a MOU with Granges, a German and French company, very large European company in the metal sector,
Yeah.
metal powders. And that's how we found that the aircraft industry, manufacturing industry, they're all convinced of the importance of using the new aluminum scandium alloys because of the lightweight, because of all of the properties. But their problem is, and that's why there are thousands of patents about this, their problem is how do we find a long-term reliable source of supply? And I mean sources of supply. Currently, it's not only that you don't have the capacity, because it's a byproduct, to increase, but it's also geopolitically challenging. You've got 75% of the world production coming from China, balanced mostly from Russia, and now about 5-10% from Quebec with Rio Tinto. So, like I say, and I was listening to Mr. Friedland, there's no competition currently in the scandium space. There's a need for allies. There's a need for numerous projects to come in production in reliable, safe countries like Australia, like Canada. So the fact is, and we have that in our pre-feasibility study, EY International did a market analysis trying to determine, not based on the supply and demand, but if there was long-term, safe, reliable material available, with all of the patents and all of the properties, enormous interesting properties of these alloys, what would be the market? Well, you start on a 20-year period from 0 to about 2,000 ton.
Yeah.
So 2,000 ton a year, our project calls for about 100 ton a year of production, and that would be the largest.
Is your project, once you get going and you get to that 100-ton level, scalable upwards?
Oh, yes, absolutely.
So
We've got
you're at
about
150, 200 tons?
Yeah, absolutely. And now that we've decided to have a permanent road going west to Shefferville, the
Yeah.
logistics is going to be able to handle a lot more than 100 ton. The reality of our project, currently we've got resources that would call for about 50 years initial mine life, but
All right.
the TG zone is open in all directions.
All
But
right.
that's one of 5 similar size anomaly. All of them have been either drilled or sampled in surface. They're all
Yeah.
open pit possibilities in surface. So we've got about 47 square kilometer of property, and it's one
Yes.
of the 5 main zones. So it's going to be recognized as a long-term safe supply.
Great. Excellent. Well, you're going well there. And it was good to hear the story, because it's obviously on the move now.
Absolutely. I'll
Thank
gladly
you very
discuss
much.
further more with you. Bye.